Okay, so here the question is, which statement cannot be written as a true biconditional? So a true biconditional means that the truth value of one statement guarantees the truth value of the other. So for example, this is written usually as P if and only if Q, and it just means if P is Q, that must mean that Q is also true. And the reverse, if P is false, then that guarantees that Q is also false. So one guarantees the other. And we said if P is true, then Q is true. Well, if Q is true, then P is true. If Q is false, then P is also false. That's the true biconditional. So as we look through these statements, we have to read them both ways and say, okay, do they imply each other both ways? For example, we'll jump here to the last one. If I am born in New York, then I am an American. Well, that could be true, right? If you're born in New York, then you could be an American. But does it guarantee it? No. If you are an American, does that automatically mean you were born in New York? No, it doesn't. So it doesn't read both ways, right? So that's not a true biconditional. It doesn't work both ways. If Bob is a programmer, then he works for Google. Well, that could be true, but imagine, if you work for Google, does that guarantee you're a programmer? And reverse, if you are a programmer, does it guarantee that you work at this company? Absolutely not. So we have two left, and the first one here seems tempting. If two lines are congruent, then they have the same measure. Well, congruent just means, let's say I have a line over here. Well, this line, let's say over here, pretend it's the exact same length. Well, they are identical except for what? Well, they're in different locations. That's what congruent is referring to. It's just a word we have that helps us describe this idea that two things can be equal, but in different locations. So the question is, if two lines are congruent, then they have the same measure. Well, that's usually true, right? If they're congruent, then they have the same measure. That's fine. However, if two lines have the same measure, does that mean that they're congruent? No, absolutely not. Let's say I have a line that's crooked and forms some kind of angle. So here, this line could be equal in measure, right? If two things have the same measure, here it doesn't even say that two lines have the same measure. It just says, right, these two things have the same measure. That means then that two lines are congruent. So no, it's not guaranteed. It could be any shape, and with the measure, it could be a curve and have the same measure, maybe a small circle or something. It doesn't guarantee that it's congruent. It just guarantees that its length is equal. So that's not a guarantee, and what's left is the answer. If two angles have the same measure, then they are congruent. So if I have an angle here, right, and then I just copy this angle, right, and I move it somewhere else, well, these two angles have the same measure, right, and that by definition means they're congruent. And if two angles are congruent, you could read the other way, then they do have the same measure. That works both ways. Right? There's no way to set another measure of this angle so that's not congruent to the other. Alright, hope this helped.